Vegetation data typically form a continuum of species composition and site conditions, within which it is difficult to see the general structure without the use of mathematical tools. Therefore, various classification methods are widely used in vegetation ecology, as they allow for a simplified and systematic view of complex vegetation patterns. They arrange vegetation releves according to their similarity, which in turn facilitates the identification of groups, particularly where more pronounced changes in species composition occur. JUICE.net provides access to a range of classification methods implemented in the R environment for this purpose.
In practice, two main approaches to vegetation classification are distinguished: non-hierarchical and hierarchical. Non-hierarchical methods, such as k-means, work with a predefined number of groups and aim to find the most appropriate partitioning. Hierarchical methods, such as twin-span or various agglomerative techniques, create a tree-like structure in which similar releves are gradually merged. All of these methods operate on a distance matrix that expresses the degree of similarity between vegetation releves. Data transformation prior to calculating distances is crucial. Without it, a few highly abundant species could overshadow the importance of less common but ecologically significant specialists associated with specific environmental conditions.
Among hierarchical classification methods, the flexible beta method is considered the most versatile. By adjusting the beta parameter, it allows users to control the clustering process, from forming clusters of comparable size to producing more compact and internally homogeneous groups. The most generally recommended starting point for classification analysis is to use the flexible beta method with a beta value of -0.25, Sorensen dissimilarity, and square root transformation of cover data. The output of the classification includes a dendrogram, a sorted list of releves, and an overview of selectable group numbers. Selecting, for example, 5 groups will display 4 separators in the table, marking the cluster boundaries. Choosing 10 groups will insert 9 separators. The Step Back button allows you to quickly return to the original ordering of the dataset, making it easier to visually compare the outcomes of different parameter settings.
Classification of a vegetation dataset is the first step toward understanding its internal structure and the ecological relationships among individual releves. It serves as a starting point for further data analysis, whether through visualization using ordination diagrams or through the identification of consistent species, composition using diagnostic, constant, and dominant species.